I am Summer.
And I'm Carl.
In this short presentation, we're going to tell you about student-generated videos capturing learning one frame at a time.
Last August, when Summer and I were discussing preparation for the upcoming semester, Summer mentioned in passing that she had used, in the previous year, student-generated videos as a mean of assessment in addition to the traditional midterms. I became immediately interested in collaborating with her to attempt something similar for our upcoming chemistry courses.
Both Carl and I had already been making our own screen capture videos to supplement our synchronous online lecture presentations. In so doing, we realized that the production of a video which involves images, symbols, animations, and audio is a powerful way to communicate chemistry concepts. And to do this effectively, one must have a good grasp of the subject content. We thought, therefore, that student-generated videos would be an effective way for students to display their learning. We believed that this would be an authentic approach for student assessment, one where students would be actively involved with the process with little collaboration with their peers.
The idea of using student-generated videos as a means of assessment is the result of two converging trends. One trend is the fact that screen capture video production has become increasingly easier to do. There are many freely available web plugins and platforms that provide ample video storage space. Second, in the spirit of inclusivity and diversity, educators are being encouraged to find alternative, authentic, and meaningful ways for students to make evident their learning. Assessment involving student-generated videos promotes digital literacy, which is an important transferable skill, provides low-stakes environment, and taps into multimodal representations, which are especially important for communicating chemistry concepts at the macroscopic, microscopic, and symbolic levels.
Our approach was inspired by an article in eMentor written by Lane Morsch, in which he describes an iterative process of tweaking a video assignment, which he calls student-author video vignettes. While I was personally familiar with using Kaltura as a screen capture video software platform for my previous workplace, this was not available at Okanagan College in September 2021 when we started the project. We therefore recommended students to use the free Chrome plugin Screencastify. This platform allowed students to make up to a 5-minute video with some modest video editing capabilities and also store the videos on Google Drive. Therefore, students could share a link to their videos when they submitted their assignments to our LMS, Moodle.
The following slide shows the timeline for the assessment approach. From the first lecture, students were introduced to the project and guided to more information in our Moodle pages. To ensure that the students were able to make a screen capture video, they were required to make a 30 to 90-second practice video by the end of the second week of the term. As support, the following were supplied: a video tutorial on how to use Screencastify, a sample video made with Screencastify, a checklist of general tips in video making, and a grading rubric.
The students were then provided with a list of topics related to the content that would be tested in each of the midterms. I had 2 midterms in my general chemistry class. Therefore, my students were provided with 2 lists and were required to make 2 screen capture videos up to 5 minutes. They were asked to choose a topic about which they struggled so that they could improve their understanding. Here's a sample example that I used in preparation for midterm 2. The question first asked them to explain observed trends on the periodic table. Then they need to explain the trends of ionization energy and electronegativity. And finally, they need to explain the dip in ionization energy between nitrogen and oxygen.
As I had 3 midterms in my second-year organic chemistry course, students prepared 3 videos in addition to the practice video. Here is a sample used for the preparation of the 3rd midterm. This question was about stereochemistry.
The students submitted their video on the Friday night, the week before the respective midterm. They therefore received feedback on their video prior to the midterm. This is a short clip of a student video in response to a question about the trends of ionization energy on the periodic table.
So, for example, if we're taking a look at nitrogen and oxygen, you would think that oxygen has a higher ionization energy than nitrogen, but that's actually not the case. And we need to take a look at the electron configuration in order to discuss this. So for nitrogen, their outer shell is 2p3, but for oxygen, the outer shell is 2p4. So it's going to be a lot easier to remove this electron from this paired electron, rather than removing an electron from this half-filled orbital. So therefore, the ionization energy is going to be a lot higher for nitrogen than it is for oxygen.
In this short video, the student discusses the energetics and strains of a hexagon ring adopting a chair conformation.
Here I have the 2D representation of my methyl cyclohexane. Now based off of this, you would expect it to be a flat ring. But in reality, if we look at our 3D model, it adopts sort of a zigzag pattern, or what's called a chair, with the headrest here, the leg rest here, and the flat part. This is due to the tetrahedral nature of the bonding of the carbons.
In this video, the student discusses the various structural and stereoisomers associated with dibromocyclopentane.
Each of these boxes have the same, obviously same molecular formula. That's what isomers are. But they've also got the same connectivity. But they're not exactly the same. They have different configurations, which means they are stereoisomers. And this can be broken down even further. Ones that are non-superimposable mirror images of each other, like this one and this one, or this one and this one, are called enantiomer.
Overall, both Carl and I are glad that we attempted this alternative assessment. It was fun to see some of the representations created by the students. It was also really nice to hear some quiet students present who typically wouldn't participate much in lectures. A lot of students' personalities come through these videos, which was really nice to see.
Remarkably, some students displayed a much better understanding of the material in the video as compared to how they typically performed on midterm exams. Some students were motivated through the process of the video making to explore the simulations and animations in greater depth and appeared to arrive at a greater understanding than they would have without this experience.
On the other hand, some of the videos were poorly prepared. Because of poor sound quality, poor graphics, and poor organization, it was difficult to see the students' level of understanding. In other cases, the videos were well prepared, but the students were not careful in ensuring that the chemistry concepts were correct. Some students also ran into technical problems where Screencastify plugin did not work on all devices.
Unfortunately, several students left the video assignment until the last moment, that is, late Friday night. Sometimes they would then run into technical problems, and I was reluctant to answer emails at 11 p.m. on Friday night. Another issue was that, especially with the first round of videos, students attempted to do too many annotations and edits with the limited editor from Screencastify. This was frustrating for the students because at best it was too labor-intensive and at worst resulted in them losing their work because the editor crashed. Lastly, some students commented that while they felt they learned in the preparation of the video, the actual video production was time-consuming and didn't contribute to their learning from their perspective.
Going forward, here are some ideas for the next round of this assessment. We could reduce the number of videos to a practice video and a midterm video. We would support students in using several screen capture software, but strongly encourage limited editing. We could ask students to submit their PowerPoint presentations or scripts before the deadline of the video assignments, And finally, have students submit their MP4 videos through Kaltura, which is now available in our Moodle platform. Thank you so much for your time and attention. Please let us know if you have any questions. Bye.